Welcome everyone. This is a series of videos on relational databases and SQL. We're going to move very quickly through a discussion. First thing we need to talk about is what is a relational database. It's a database based on a table structure that is columns and rows. So it's very much like a CSV. But unlike a CSV, it allows a number of advantages for storing data and also for storing complex relationships between different areas of data. Relational means tabular, columns and rows. A database may contain many tables, which means you can have multiple tables in one database, and oftentimes those tables are describing a larger data set that makes up multiple tables. And one simple example would be if you wanted to have a table that contains businesses, a list of businesses, but then you also wanted to show the business's employees. You would usually use a separate table to list the employees and one table to list the businesses. And so we use something called primary keys, which is usually an ID number, to connect tables and to relate data between one table and another. Some folks think that relational means the fact that these tables relate to one another. Let's say a table of companies and a table of employees for the companies. But that's not really it. Relational just means tabular. It just means columns and rows. So it is like a CSV, but relational databases have a huge number of advantages over CSV or some other table structure like Excel. And that is that relational databases are designed for speed, and that also has to do with working with very large data sets. So relational databases can hold huge amounts of data and access that data very, very quickly, especially when you're selecting individual rows or groups of rows from a table. It can execute complex queries on the table or tables very easily. Concurrency, which means that multiple people can be working with the same data at the same time. Complex relationships with data, like the two tables I talked about. And integrity. When we talk about the tables that we work with, every table has a structure. And this happens to be what a table structure looks like, or how it's illustrated in MySQL. We're going to be working with a database called SQLite, but they're very similar in many respects. And you can see when you see field means a column name. This isn't an actual table where we're storing data. This is actually describing what the table will hold. And so still think about a table as a CSV file with column heads. The field values that you see there are the column heads, the date column, for example, or the market ref column. And then the type of value that you find in the column is described and specified in this table description. This is a table description. It also shows whether or not you can have a null value in the column, whether it's a primary key, what the default value is. Relational databases allow us to specify what we're going to allow in the table and what we won't allow. This is what I mean by data integrity. For example, if the column is specified as an integer column, you won't be able to put a string into the integer column. Same thing with float. That means that the data inherently has integrity for the most part if your table structure and requirements are very strict. So this is another big advantage of relational databases. Also, most databases are accessed over a network. Now, for our exercises, we're going to be using a file-based database because it's just very much easier to work with. But usually, because we have concurrency, that is many people working with the database at one time, usually the database sits on a server on a network and we access it through the network so that multiple people can make requests through the network to access the database. And so we can have that advantage of concurrency. We're going to use SQLite, so that's a file-based database. So we won't have actually a lot, we won't see a lot of those advantages. For example, we won't necessarily see that the table requires certain data types, although we will set the data types. And we're not going to be seeing any concurrency. We won't have multiple people accessing the table at the same time. But it is much easier to work with, and we're going to find that many of the things that we need to learn and do in this session are fully realized by working with SQLite. So that's what we're going to look at, I think, next. SQLite is lightweight. It's actually used. It's actually used in a production environment, in a professional environment, where in places where we don't have a lot of memory or a lot of processing power. For example, they often use SQLite in small devices. Raspberry Pi or other devices that need to make use of databases will often turn to SQLite because it is so light, and that's why it's called that. So that is a brief introduction to what relational databases are, and now we're going to go into the mechanics of working with our SQLite database and issuing SQL queries.